Hello and welcome to New Frontiers on CCTV International. I'm Ji Xiaojun in Beijing. In today's program, we are continuing with our major series about Chinese civilization. In it, we are attempting to illustrate the evolution of Chinese civilization through an investigation of archaeological discoveries, historical sites, and cultural relics. And today, we are going back 1,000 years to the Song Dynasty. This was a time when China experienced quite remarkable development in the field of science and technology. Take as an example the four great inventions of ancient China, namely paper, printing, the compass, and gunpowder. Well, it was under the Song Dynasty that they really came to the fore and their use flourished. All in all, Song, with its advanced technology combined with the prosperous economy and rich culture, was another golden age in Chinese history, following on from the Tang Dynasty.
After the glories of the Han and Tang dynasties, China entered the Song Dynasty, which lasted from the year 960 to the year 1279. The Song Dynasty is considered a high point in Chinese history, a time when China led the world in science and technology. The Song Dynasty saw the rise of numerous scholars in many fields, and through their efforts, science and technology in China reached a level that makes today's Chinese still feel proud. This is Kaifeng City in Henan Province. Under the name Bianliang, it was the capital of the Northern Song Dynasty. During the summer of the 7th year of the reign of Northern Song Dynasty Emperor Xinying, the year AD 1074, the city suffered a devastating drought. Hope that there would be an end to the drought was rekindled when, for a number of days, dense dark clouds appeared over the city and the people heard sounds that carried the promise of rain. However, no rain came and the drought continued. Emperor Shenzong, more disheartened than ever, waited anxiously for the arrival of a man by the name of Shen Kuo. When the emperor asked Shen when it would rain, he replied, "It will rain heavily tomorrow." His answer astonished all the other officials present, but Shen Kuo understood that over the summer a considerable amount of water vapor had accumulated, and that the continuous cloudy days implied that the water vapor had already gathered. Shen Kuo knew that when the ground was again exposed to the heat of the burning sun, the interaction between the water vapor and the ground heat would make rainfall a certainty. This instance of a successful prediction of the weather is recorded in a famous book written by Shen Kuo called Dream Pool Essays. Shen Kuo was born in Qiantang in what is now the city of Hangzhou. During the reign of Song Dynasty Emperor Xinying, he was appointed head official of the Bureau of Astronomy, an important department of the Song Dynasty responsible for the observation of astronomical phenomena and the design of calendars. In effect, it was rather like a national astronomical observatory.
宋代实际上是中国古代非常了不起的一个时代了，就是说它和前朝相比，应该说发生了很多的社会的方面、科技的方面、思想的方面，都发生了很大的变化。陈寅恪就是说的，中华文明眼见到宋代就达到了登峰造极的地步啊， 对后世的影响也非常之大。重文轻武，也就是重视教育，然后呢把这个科举制度大大的完善。在宋代，也就是说，它是一个非常重视人才的一个时代。
People in China, as elsewhere, were unable to explain the mysteries of solar and lunar eclipses, and so they conceived of a universe in which the sun and moon could be eaten by a monster called the sky dog. We now know that 3,000 years before, during the Shang Dynasty, ancient Chinese inscribed the world's earliest records concerning solar eclipses on animal bones and tortoise shells. During those early eras of human history in which man set out on his earliest attempts at scientific exploration, ancient Chinese produced significant achievements that laid a solid foundation for the scientific development that characterizes the Song dynasty, especially in the area of astronomy. On a morning in July of the year 1054, an unknown nova appeared in the eastern sky over Bianliang city. Observers named it the Visiting Star. The sudden appearance of this nova alarmed the Song dynasty's Bureau of Astronomy, as this was, after all, an era in which people mystically connected happenings in the secular world with celestial events. What then did the sudden arrival of this nova portend? A year later, the visiting star suddenly vanished, but by that time, astronomy officials at Kaifeng Stellar Observatory had made records of their observations of the nova in daylight hours 23 times. In so doing, they provided significant scientific clues for later generations.
This 个星为什么重要呢？因为现在我们天文学家在那个地方，在天官星，也就是金牛座的那个地方，知道有一个谢障星云。这个星云就是当时这颗克星，也就是这个星星。也就是超新星爆发的这么一个遗迹。那么根据这个，我们知道现在这个时间差和过去的时间差，那我们就可以得到一些很多的物理参数，比如说就关于爆炸的速度。这样对于天文学家来说，构建这个宇宙的演化、恒星的这个生成、恒星的这个演化理论都是非常有帮助的。
By the year 1072, Shen Kuo had been appointed head official of the Bureau of Astronomy, and in this capacity he took charge of the design and development of astronomical instruments. As well as this, during his tenure he wrote 3 famous treatises in succession: Research on the Armillary Sphere, a skeletal celestial sphere with a model of the Earth placed in the centre; Research on the Clepsydra, a device that measured time through flowing water; and Research on the Sundial. These 3 important treatises had a profound impact on later inventions and on the nature of improvements made to important astronomical instruments.
沈括主要的工作不仅仅是把前人的东西给归纳了，而且有了一些个从理论探讨上和实践上，增加了一些新的东西。他这些新的东西呢，就是在他给皇帝的建议，就是混一仪里头就讲的比较清楚。他讲的10几点的改革建议，我们大部分都可以在现在存下来的这个混仪上看出痕迹，找到证据。
Shen Kuo was in fact something of a polymath whose brilliance extended to many fields of study other than just astronomy. Well, as a man of many talents, he was not alone in the Song dynasty. Su Song, for example, has gone down in history as the inventor of a hydraulic-powered astronomical clock tower, although he was also known as a statesman, calligrapher, and botanist, to list just a few of his accomplishments.
In the year AD 1092, famous Northern Song dynasty astronomer Su Song invented the astonishing water-driven astronomical clock tower. Following ancient records, modern scientists have been able to produce a 1/5 scale working model of Su Song's prototype. In his invention, Su Song employed several world firsts in the design history of astronomical instruments. His clock tower is not only recognized as the forefather of the modern clock drive, which keeps the telescope synchronized with celestial motion and the Earth's rotation, but also the progenitor of the active roof of the modern telescope observatory.
这个输送所做的这个水印仪象台，那是一个非常了不起的一个天文仪器。它分3层，上面是这个浑仪，中间呢是浑象， 在下一层呢，就是我们说的报时的系统，也就是它集观测和演示和这个授时于体，而且是一个用水力来推动的，那也就是一个自动化的一个体系。可以说这个天文仪器在宋代的达到了一个非常高的高峰。
1,500 years ago, famous mathematician Zhu Chongzhi calculated that the approximate value of pi was 3.1415926. Before that time, the value of pi used in Chinese astronomical mathematics was calculated as being equal to precisely 3. Zhu's record would not be broken by his foreign counterparts until 1,000 years after his death. His remarkable achievement has led experts to conclude that by that time, astronomy in China had been leading the world for more than a millennium. As Shen Kuo was the first scientist in the world to initiate the concept of the abridged armillary, it is clear that the world's first abridged armillary was invented in China. This instrument worked as both an equator globe and a multi-purpose measurer. To a certain extent, then, the ancient Chinese caused astronomical observation worldwide to take a significant step forward. In the city of Suzhou in Jiangsu province, one can examine a large, well-preserved Southern Song Dynasty stele. This stele, 2.16 meters high and 1.06 meters wide, is inscribed with the world's largest star chart. For several years, from the year AD 1078, the Bureau of Astronomy of the Song Dynasty Court systematically carried out observations of the heavens and made extensive records. During the Southern Song Dynasty, astronomers drew up a star chart based on those records and had it inscribed on the large stele. The stone-carved star chart of Suzhou, on which appear no less than 1,431 stars, is the biggest and earliest star chart in the world, and it is so detailed that modern astronomers find it incredible. In the case of the position of 266 fixed stars, discrepancies in accuracy between what is recorded on the stele and measurements made today using modern measuring standards are very small indeed. The on-the-spot approach to conducting research also promoted the design of calendars during the Song Dynasty. In the Tongtian calendar introduced in the Southern Song Dynasty, the discrepancy in the length of the year suffered by earlier calendars was reduced to just 22 seconds. This means it was every bit as accurate as the Gregorian calendar still used throughout the world today, yet the Tongtian calendar was devised 400 years earlier than the Gregorian calendar. Ancient Chinese followed the practical notion that astronomical observation should serve agriculture, and the most direct manifestation of this was seen in the continuous corrections made to calendars throughout the various dynasties. Early in the Northern Song Dynasty, a luni-solar calendar was introduced, but in it there was a discrepancy between the phases of the moon and the terms of the sun, and this often resulted in delays to important farming events. In order to establish the precise relationship between moon phases and solar terms, Shen Kuo proposed the idea of a calendar with 12 solar terms.
那这种历法可以说一改过去的传统，过去都是我们叫阴阳合历，就是把24节气和月亮的这个朔望月合在一起的。而他认为这个东西比较复杂，所以说干脆就把朔望月的那一套东西给它撇开，自己完全做一个纯阳历这个东西。这同我们现在所用的公历的想法是可以说如出一辙的。
From the time of the introduction of the 12 solar term calendar in the Song Dynasty, agricultural production was kept in line with farming seasons. The Grand Canal had been built during the reign of Emperor Yang of the Sui dynasty several hundred years before, and by the time of the Song Dynasty, it had been developed into a golden waterway for goods being transported between North and South China. Paddy rice produced in South China was shipped northward to Bianliang City. During the Song Dynasty, a new type of canal lock was invented. It was not until 400 years later, in the year AD 1373, that a similar lock was invented in Europe.
在中世纪的欧洲，这个播种量和收获量的比是1:5到1:10，而在宋朝的时候，播种量和收获量之比是1:100，也就是说， 宋代的粮食单产和粮食产量是欧洲的10倍甚至20倍。
Agriculture has always been the foundation of all human civilizations, and certainly the advanced state of the science and society of the Song dynasty was to a great extent the result of the advanced level of the nation's agriculture. As the most prosperous city in the world of its time, Bianliang City had a population of 1.5 million. Not surprisingly, agricultural production was the national priority. Agriculture in the Song dynasty was advanced, especially in South China, where rotational farming was already in operation. Early maturing and highly compatible paddy rice varieties also helped facilitate the efficient and full use of land. Farmland, originally not suitable for crops, was improved through fertilization to the point where it could sustain high-yield rice fields. Very often, 2 or even 3 harvests a year were possible. Modern experts in agriculture regard the Song dynasty as a Green Revolution era in ancient Chinese agriculture.
"在宋朝的时候，中国的人口首次超过了1个亿，也就是说，宋朝的农业就已经养活了当时世界上最多的人口。
The 4 great inventions had initially an enormous influence on the development of Chinese civilization and later a far-ranging global impact. All 4 were invented prior to the Song dynasty, but it was under Song that their full potential began to be realized.
Over the long period of the evolution of Chinese civilization, we can trace the lives of numerous great historical figures. Through their wisdom, intelligence, and remarkable achievements, the Chinese nation was able to stand proudly at the pinnacle of the science and technology of the ancient world. Among those geniuses were the Duke of Zhou, who observed the sun's shadows in front of the Ngomon. There was Lu Ban, who made scaling ladders for the state of Chu. There was the profound and brilliant philosopher Mo Zi. There was Li Bian, who constructed the great water conservancy project known as the Dujiang Weirs. And then there was Zhang Heng, who invented the first seismograph and succeeded in locating the epicenters of earthquakes. There were also many skilled craftsmen such as Bi Sheng, who invented movable type printing. These greats of the ancient world laid the cultural and scientific foundations for the appearance of China's 4 great inventions during the Song dynasty.
这个中国古代科技发展最重要的时代是在宋代，古代所谓4大发明吧，纸比较早的，那么这个印刷、罗盘，和火药，主要的应用阶段都是开始于宋代。
At an intersection of the Beijing-Hangzhou Grand Canal is the beautiful city of Zhenjiang. In order to commemorate the famous Chinese ancient scientist Shen Kuo, in 1985, the people of Zhenjiang rebuilt Dream Brook Garden, the place where Shen Kuo spent the last few years of his life. It was in this garden that Shen Kuo completed his famous work, Dream Pool Essays. According to Dr. Joseph Needham, who was well versed in the history of Chinese science and technology, the encyclopedia Dream Pool Essays is an extremely important landmark in the history of Chinese science and technology. In this work, recorded in great detail, are the scientific thoughts and technological breakthroughs of the Song dynasty. Dr. Needham enthusiastically praised Shen Kuo as the most outstanding scientist in the history of Chinese science. Shen Kuo was indeed a genius. When he was made a military officer in Yan'an Shanxi province, he discovered the region had an abundance of petroleum. After carrying out a few experiments, he found that soot made from the smoke of burned petroleum could be used to make writing ink. He then concluded it would be an excellent substitute for pine soot and that using the substitute would reduce deforestation. He then ordered that his new writing ink made from the soot of burnt petroleum be produced in batches, and he rightly predicted that petroleum would be used greatly in the future. But as well as that, Shen Kuo was the most direct participant in and chronicler of the four great inventions of ancient China. Originally, gunpowder was used as a kind of medicine to dispel plague and treat ringworm. Earlier in the Tang Dynasty, Taoist alchemists had discovered that when sulfur, saltpeter and charcoal were heated together, the result was a chemical reaction that caused fire. From then on, this medicine that could be set on fire was known in Chinese as Wo Yao, or fire medicine. It was during the Song Dynasty that people discovered how to harness the force generated by the discharge of burning gunpowder and invent the fire rocket, the predecessor of all modern rockets. According to ancient Chinese legends, the Yellow Emperor invented a device that was known as the south-pointing chariot, the instrument that gradually evolved into the modern compass. The earliest documentation concerning the compass can be traced back to before the Qin dynasty, well over 2,000 years ago. During the Han dynasty that followed, the famous philosopher Wang Chung recorded that when a piece of lodestone carved in the shape of a ladle was balanced on a round bronze plate, the handle of the ladle would point to the north entirely by itself. Before the Song dynasty, this compass, known as the South Pointer, was not particularly accurate. But while trying to improve the precision of the compass, Shen Kuo made a great discovery regarding the globe's magnetic declination angle. Although the compass had already been invented before the Song dynasty, it was not until the time of the Song dynasty that the earliest magnetic compass could be used for navigation. After the magnetic declination problem had been solved, the compass went on to be highly important for navigation at sea. With Shen Kuo's new improved compass, a large boat in the Song dynasty could travel much further, and over time, the compass invented by the ancient Chinese was exported and used in ships across the world. Several hundred years later, when the American continent was discovered, it was thanks to the compass. By that time, the compass, an invention of the Chinese, had written a truly magnificent page in the history of world civilization.
The adoption of the compass in navigation, of course, meant that ships were less likely to get lost at sea. Ultimately, it also made it possible for ships to travel further away from China. Well, it wasn't long before other countries were making use of compasses. Thank you for staying with us on today's New Frontiers, and join me again next time when we'll bring you more about the development of Chinese civilization and the Song Dynasty. I'm Ji Xiaojun from CCTV International. Bye for now.